Okay, Unit 7, Day 3, we're going to talk about transforming the exponential functions that we learned how to graph yesterday. Just remember, we can kind of use some of those shortcuts, initial value and those kind of things. But also remember that if you apply things like say add stuff to the end of the function or add things to the x, that's going to change, it's going to shift it up, down, left, and right. Okay, so the graphing form for this, just real basic here, like you have y equals ab to the x, where this is your y-intercept. We called it the initial value before, that's your y-intercept, and this is your growth or decay factor. So that tells you as you move to the right what you should be multiplying by, and as you move to the left what you should be dividing by. So decay factor, so it's growth or decay factor. So first off, remember that if we take the whole thing, the function, like if you think about last unit, the square roots, we had the square root of x, and if we added or subtracted some number to the end, maybe I can't remember if it's h or k, which one we want to call this. I think this is k. If I put a k on the end, this meant up or down. And then if it was inside the function with it, we'll say h, that was left or right, and it was kind of the opposite of what you thought. Okay, so on this one, to be at the end of the function, it would have to be on the end. So it could be y equals abx plus or minus, and I'll put a k here, that would be up or down. So if there's a number on the end, in order to be with the x, like here, this is inside the function with the x, in order to be with the x, it would have to be up here plus or minus h. And if it be up in the exponent, that would be left or right. And it's the opposite of what you think. Okay, so this guy here, I want to graph the function 3 to the x, but I'm going to move it down 4 units, because this on the end here means down 4 units. Okay. Well, the original asymptote for an exponential was right here. So if the whole thing's moving down 4 units, that means my new asymptote will be right here. So my asymptote will be at y equals -4. And I can kind of go from there now. So consider that as your new x-axis. Okay, this says the base is 3. That's your growth factor. So what's your y-intercept? Well, your y-intercept is the number out front here. This is like 1 times 3 to the x minus 4. So there's your y-intercept, your initial value. So I'm going to go, I was here, that was at 1. Well, now I got to move that down 4 units, now I'm here. And then from this point, as I move to the right, so if I go to the right, I need to triple it. So if it was 1 above, now it's going to be 3 above. If I go over 1 more, it's going to be 9 above. If I'm moving to the left, I'm going to divide by 3. So if I'm 1 above, divide that by 3, now I'm going to be 1/3 of the way above, and then 1/9 of the way above, and then it's getting so small I can't tell the difference, but it's going along the x-axis and shooting up this way like that. Now your domain is still left and right forever. But the range, yesterday the range was always 0 to infinity. But here you see I've got some y's down here because as I come up the y-axis, right there I'm starting to see a graph. I'm at -4. So this is -4 to infinity. Is -4 ever included? And this one, since -4 is the asymptote, it never actually touches -4, so that's a parenthesis. It never actually gets there, so we don't want to count that as one of the answers. So down here, remember, this is like a 1 out front right now, like 1 times 0.0 or 0.5 raised to the x minus 4 power. So my original graph for this guy would be, I would start at 1, kind of put it real lightly, I'd do it 1, and then as I move to the right, I'm going to be cutting it in half. And it's going to go real small, and it's going to go along this asymptote right here. Now there is no up or down shift, there's no number on the end, so that is still my asymptote. If I'm cutting in half going to the right, I'd be doubling going to the left. So this was the original without that shift. Now the -4 right there, that means 4 units to the right. So I'm going to take all these points and go 4 units to the right. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 4, and it kind of does this, and it's going to go along that asymptote and go this way. So the domain on this is still negative infinity to infinity. The range is from 0 to infinity. 0 is not included because it never actually touches it, because 0 is the asymptote. So y equals 0. Okay, let's flip it over. Now, when I made this Word document, this was on the front page, and there were 3 on the second page, and there was no third page. But for some reason, when I hit print, this moved down just a little bit onto the second page. So I apologize. This is three pages long, and we don't normally do that. But this guy here. Now we've talked about this plus 1 means up 1. What does a negative out front mean? Well, negative out front means a flip. Flip about the x-axis. We've done all those before. So the original function, just 2 to the x, would look something like this. It would start, because the number out front, it's a 1. This is like negative 1 times 2 to the x plus 1. So that's your initial value. Let's see here. So yeah, so I'm going to go, this would be a negative 1, but I got to go up 1. Well, maybe I'll just graph without. Let's do without the shift. So let's do negative 1. And then as I move to the right, I need to double. So I'm 1 below, now I'm 2 below. Then I'm going to be 4 below, so I keep doubling. As you go this way, you cut in half. But now move all those points up 1 unit. So now the asymptote would be up 1 unit. This point would be up 1 unit, up 1 unit. It looks something like this. Okay, so the domain is still negative infinity to infinity. Now the range on this one, it always does exist. So it's going to start at negative infinity. It's going to come up to 1. Does it ever touch 1? No, because 1's the asymptote. So y equals 1. So it never actually gets there, but it comes awfully close. Number 4. Okay, here we go. So now we actually have a number out front. So there's the initial value. And if I don't do this shift yet, I just say starts at 2. As I go to the right, it triples, so now it becomes 6. And if I go 1 more, it's going to be off the chart. As I go to the left, it's going to be 1/3 of that. So just kind of eyeballing what's 1/3 of that. It's about right here. And it would be on that asymptote. But this guy here says take everything left 2 units. So I'm going to take all these points left. Now notice that asymptote does not change. It's going to stay right there. So I'm going to take everything left 2 units. And it's still going to follow that same asymptote. Something like that. Domain's negative infinity to infinity. The range would be from 0 to infinity. 0 never gets touched. It's never going to get there. The asymptote is y equals 0. Okay. This guy, I'm going to be moving things down 2 eventually. But I'll just graph without that. Sorry, I'm off the charts here. So this is a down 2. I'm going to cover that up. I'm going to graph this as if I don't have the down 2 and then add and move everything down. So the asymptote is going to be a 0. It starts at 4. 1, 2, 3, 4. And then as I go to the right, take 3/4 of that. So it'll be a 3. 3/4 of that. Be somewhere in here. And I'm just eyeballing what 3/4 is. So 3/4 of that. As I go this way, instead of taking 3/4, I'd do 4/3. So it's going to get bigger, which maybe I'll just use my calculator for that. Let's see. So right here, I'm at 4, and I'm going to multiply by the reciprocal 4/3. So it'll be a 5 1/3. So it'll be a 5 1/3, be somewhere in here. Whoops, a little bit lower, somewhere in there. Now, take all these points down 2 spots about here. So 1, 2, 1, 2, 1, 2, 1, 2. The asymptote goes down 2, so you can kind of get the idea. Just, oh, whoops, I don't want to start there. I want to start right here. So it'd be this guy. It's going to come down and go along the asymptote. Go that way. I accidentally connected the 2 graphs. This point's from the graph before it shifted. So there's that. So domain's negative infinity to infinity. The range would be from -2 to infinity. Again, -2 is not included. The asymptote is y equals -2. Okay, now let's flip it over. We got one more. Whole lot of stuff going on here. So if I take out these transformations, it'd be -1/2 4 to the x, and then I'm going to take that left 1 up 2. So I'm going to graph this first, and then I'll throw in the transformation. So I'm going to start at -1/2, about right here, and then I'm going to quadruple that. So if I quadruple that, I'm at -2. And if I quadruple that, I'm at -8, which is going to be somewhere down here. And it would come up and go along this asymptote. But now I'm going to do some transformation. So first I'm going to go up 2. So my new asymptote would be up here at y equals 2. And all these points need to go up 2, left 1. So up 2, left 1. Up 2, left 1. Let's see. So it'll be a 6, 2, 4. So it'll be here, left 1. So these points, not that one, I'm aiming for this guy right here. It goes like that. Okay, so my domain would be -infinity to infinity, and my range would be -infinity up to 2, not including 2, and you got your asymptote of y equals 2. So hopefully that helps. Just with our experience of transforming, I don't think we need to get doing too much work with that. You can probably kind of see what's going on here, but if you have questions, need more help, let me know, and I'll definitely try to help you.